Hi, welcome to Physics Teacher. In this video I'm going over a lab that I do with my grade 12 physics students where we're going to use LEDs to measure Planck's constant. So here's the equipment we're going to use. We have a power source, it's just a 6-volt battery. Then here we have a potentiometer, which I can use to adjust the voltage going through the circuit. So as you can see, I can turn on slowly or off slowly. It's basically a dimmer switch. I also have a resistor, because that's important. Without a resistor, I'm just going to pop the LED. And that's our circuit. Now I also have a voltage probe connected where I can measure the potential on my data interface here. Then I also have a light sensor where I can measure illumination. Now what we're going to do is we have 5 colored LEDs, red, orange, yellow, green, and blue. For each one, we're going to hold it up to the light sensor, slowly increase the voltage until we just start to see light coming out of the LED. And when that happens, we are going to take the actual voltage at that point where the LED just started to light up. Why do we want it when we just start to light it up? Well, to know that, let's first learn a little bit about how LEDs work. So how do LEDs work, and how are we going to use them to measure Planck's constant? Well, LEDs are composed of 2 semiconductors. First one is an N-type semiconductors. So silicon has 4 electrons in its outer orbital, which allows them to form nice crystals. A pure silicon crystal is a very good insulator. However, adding phosphorus or arsenic, each having 5 outer electrons, into the silicon crystal as an impurity leaves 1 electron with nothing to bond to and is free to move around. This is an N-type semiconductor. A P-type semiconductor is when we add boron or gallium, each having 3 outer electrons, into the silicon crystal as an impurity, which leaves a hole in the lattice where a silicon electron has nothing to bond to. Now when we take an N-type and a P-type semiconductor and put them together, that is what an LED is. So we have our N-type, which contains a number of electrons that are free to move, and our P-type, which contains vacant spaces where electrons can go. Some of the free electrons will move from A into the holes in B, which reduces their energy. After a short time, a charge difference forms between the 2 regions near the boundary, which produces an electric field that acts as a potential barrier to prevent any more electrons from crossing. When we connect the negative terminal of a voltage source to the N-type semiconductor, the electrons will be attracted to the boundary and a current will flow when the potential difference from the source is great enough to overcome the barrier created by the electric field. When these electrons cross the boundary and move into holes, they move from higher energy states to lower energy states. In doing so, they emit energy in the form of photons, which causes the LED to shine. When the LED just begins to glow, electrons crossing that boundary moves through a potential difference, delta V, which causes them to lose energy equal to their charge times that potential difference. And that energy is converted to the energy of a photon, which is Planck's constant times the frequency. If we equate these and look for just when an LED begins to glow, we can measure Planck's constant. Alright, so we're going to start with the red light. So let's start recording and increase the voltage. And you can see we got the point we're looking for. So right here is when we just started to get some light. So let's check that. And it looks like at that point, our voltage was 1.642 volts. All right, next we have our yellow light. Increasing the voltage. And it looks like right here we got a potential of 1.690 volts. All right, next is going to be green. Increasing voltage. Looks like right there. We get a voltage of 1.782 volts. And finally, our blue light. Increase the voltage. All right, we get a voltage of 2.429 volts. All right, so I hope you enjoyed that lab. If you want a copy of the handout, you can get it for free in the description. You can go over the analysis and calculate Planck's constant for yourself, see how far off you are from the actual value. And don't forget, if you want to see more videos like this, I have a wide range of videos. Check out my channel and all the different playlists. And if you like them and want to support more videos, please consider subscribing. Thank you.